Hi everyone, my name is Harish Nair and today I'm going to be talking about GEMA for medical transcription. I am an AI researcher at the National Research Council of Canada and I currently pursue my master's in applied data science from the University of Ottawa, where I'm also a graduate research assistant. I've previously worked as a senior analyst at Gemini, and my career aspirations and current focus includes expanding skills in data science, foundation models, and model optimization techniques to drive high impact data solutions. To talk about my project, it involves fine tuning a generative AI language model with medical transcription data. Some medical jargon, such as CT and MRI, do not have the general purpose capability for models to handle accurately. This is why an instruction tuned conversational style dataset is important, which is also HIPAA compliant and it has adaptability to various medical settings such as clinics, hospitals, laboratories. The data science methods that I used include supervised fine tuning, which is training a model on the labeled medical transcription data to recognize medical vocabulary, context, and nuances. Parameter efficient fine tuning, which applies LoRa, the low rank adaptation, by fine tuning the model on a very small subset of parameters. Quantization, which reduces memory and computational needs using 4-bit quantization, and torch.b float, which is a PyTorch computation technique for model performance optimization and inference on low memory GPUs. Model adapters, instead of saving the entire model as T5 file, you only use the small configuration JSON file to enable modular adjustments to the model. Deployment tools such as Hugging Face API for model hosting and Kaggle command line interface for data handling and model version control. Some of my learnings include memory management. I learned that over quantizing language models to formats such as Q80 or Q4 in GGUF introduces various complex challenges such as catastrophic forgetting, which I'll talk about in the coming slides. There's a trade-off between accuracy and inference speed. Quantization improves inference speed by reducing the model size and the memory requirements, but often at the cost of its accuracy. So there should be a balance, particularly in medical applications where precision is very essential. I gained experience in deploying LLMs in a resource constrained environment, as well as troubleshooting dependencies in cloud based environments. The data pre-processing step involved reducing a 5,000 row empty samples dataset having 40 medical specialties to only those categories with no more than 50 data points, which were not considered. The data was sourced from emptysamples.com and I applied TF-IDF for the transcription data as visualized by the TSNE plot on the right. This is my complete end-to-end workflow from the data pre-processing step to the deployment on Gradio UI and testing it out locally on JAN The After the data pre-processing comes the model training step. I used and experimented with two approaches to fine-tuning. The first one with the Gemma 2 billion instruct with low rank adaptation, and the next one was Gemma 2B, the base model with 4-bit quantization and quantized LoRa, as well as post-training quantization with bits and bytes and GGUF for low memory GPU setups. I leveraged Kaggle Hub for model hosting and inference, and I deployed it via a Gradio user interface on Hugging Face spaces for tasks such as response generation and efficient memory management with torch.b float 16 precision with bits and bytes config and balanced storage and compute through fine-tuning hyperparameters. I evaluated the loss metrics using weights and biases. And as you can see, I trained it for 8,000 steps over 10 epochs, achieving a validation loss of 1.019. Catastrophic forgetting is when the model loses its knowledge retained from pre-training. This happens as we lower the precision, there is a greater potential for accuracy loss, and multiple quantization steps can exacerbate this issue a lot. The GGUA format for the model that I trained is uploaded on Hugging Face and it can be downloaded to test locally. The final instruction tuned model is deployed on Hugging Face spaces, the link for which can be found in this project links slide, along with the other links for the notebooks as well as the evaluation. Thank you.